Hi, I'm Dr. Brian Fraser, and in this video, the second in the series, I will be showing how to use GDB from a text-based debugging point of view. In this video, we're going to be looking at memory access problems. Specifically, we'll look at one program that's SegFaults due to an obvious cause, and then we'll move on to look at another program that's SegFaults due to a less obvious cause. Okay, so to begin with, and this is also going to be cross-debugging. So I'm going to be running the program on an embedded Linux device, specifically in my case a BeagleBone Green, but it should be the same for Raspberry Pi or any other embedded Linux device. So let's get connected to start with. Or actually, I'll show you first the program that we're going to run. I'm calling it SegFaulter because that's all it does. If I look at the main here, the main routine, and the main function will go and, well, print out a message. I set up a variable called good, and I pass it to print pointer. And then I call print pointer again with a null pointer. So when I call print pointer, we can see what it does. Prints out the pointer itself, the address, and then it dereferences it. I've got a function here called dereferences. I just want to kind of bounce deep into functions to show what happens inside of GDB. And I get the value back from my dereference it function that just dereferences an int pointer. And I take that value and I print it out to the screen. So let's have a look at what that's going to do. First off, I need to connect to my embedded target. So that is going to be via SSH. SSH in. I've already configured up a NFS mount from my embedded target to my host. So let me run that script now. It's actually already been run, so I'm good. And I'll just access the shared drive. So here's my folder. It's a shared folder, and so I can run things that exist on my host that are cross-compiled for my target. So here I'm just going to run SegFaulter. And we can see it did exactly what it should do. It SegFaulted. When given the null pointer, and we came in here and we tried to dereference the null pointer, well, we printed out, given pointer is 0. Let me just move this down a little bit. Given pointer is 0, yep, and we dereference it, and that fails right then and there. Okay, let's debug this. So to debug it, I'm going to set up the cross-debugger. So here on the right-hand side, I've got a terminal that is going to be my host, and down here on the left-hand side, I've got my embedded target. To run the cross-debugger, I need to run gdbserver on the target. So let's do that. So gdbserver, and I say localhost 2001, and then give it the executable I wish to run, and I'm going to run SegFaulter. And now it's up and running, waiting for me to connect. I'll come back here to my host. From here, I need to run gdb-multiarch. This is a program that will allow me to do GDB sessions targeting another platform, and so the program is going to interface with gdbserver over here and allow me to do the debugging. So I do that, and then I'm going to specify what I wish to do. So I'm going to do quiet because I don't want some args or some output at the beginning, and I need to tell it the path to the executable. My executable has been compiled with debug information included. I'll show you what that looks like. So inside my make file, I have a -g in my flags that are passed to the compiler, and so that's going to compile in symbol information for debug. So my actual executable is in home directory, compute 433, public, and then my apps, and it's called SegFaulter. So now gdb-multiarch knows of the file, it knows the symbols. I can't just run it here because it's been cross-compiled. In fact, if I do try run, it doesn't work. It doesn't work on this executable. It says here, cannot execute binary file, exec file format error. So what I need to do is, of course, connect up to my debugger server. So I'm going to say here, target remote, and 192.168.7.2, and 2001. That's the port number and IP address of my target. And I connected, and down here we can see that we've actually connected here. So I could set breakpoints and so forth. We might do that in a minute, but to begin with, I'm just going to run it. So continue, and it just runs. And this program needs no input. It just SegFaults all on its very own, and we can see that it did that here. It got a seg-v, signal seg-v, segmentation fault, and it tells me where it did that. This isn't particularly in question. Inside a function called dereference on line 5. So let me do list. And list will show me the code at that point. So here it told me line 5. This was a line that SegFaulted. inside of dereference I say, well, why did it SegFault? Well, I can do print PTR. It tells me PTR is 0. I could also have done info args. It'll also tell me all the arguments. In this case, there's only 1. So this is not at all in question as to what line of code is going on here. But my question would now be, well, where did I come from? Where did this pointer value come from? So let's do a backtrace. I can also do info stack, and it would show me the stack trace. And so these are all of the different calls I had. So for main, we called printer or print pointer, and then print pointer called dereference. And dereference actually tried to dereference the value. And so we know that my problem is probably going to be somewhere up higher. So I'm going to go up the stack. So I just do up, and it tells me now I'm at stack frame number 1, index 1, from here index 0 up to index 1. And it can tell me now that, well, here's the line of code that was going to run. So let me do a list. We're on line 10. So this is the line of code that calls dereference, and it passes in P. Well, P came from here as our argument, so I can do print P. No surprise, it's still null. I got to go up one more, so let me do backtrace. I'll look at it. I'm currently here. I'm going to go all the way up to main. I'm going to go up, and we can see here that this is our obvious culprit. I'll do a list just for fun. And we can see, okay, well, we're passing in a null. Now, this is how I'd realize where the actual SegFault occurred. How to fix it? Well, in this case, my whole program is designed to SegFault, but maybe I put in an extra check here. So maybe I'd put in a check for null. So something like if value. So if P does not equal null. In fact, I can just do the kind of the C standard. If P, then dereference it, print the value. Else printf error, the value is null, the pointer. And we're not going to then dereference it. I'll just rebuild this. I'll show you how we get out of that. And I say, okay, now I fixed the bug. I'm still stuck in the debugger here. I can't, if I control C, it doesn't get me out of this. I've connected up my cross-debugger, and so the easy way to do that is just quit. Or I could have told it to continue again, and it would have then crashed out. Now that I'm back here, I will rebuild. I haven't done so already. I've rebuilt. That redeploys it to my NFS share, and I can rerun it. So SegFault. And here we can see it actually is now we fixed the bug. So I handled the null explicitly. Okay, so that's the quick view of what it looks like to debug a SegFault. Let's now look at something that's not quite so obvious. Let me run the program first. So this is called array entry crasher. It's very similar to the array entry bad data that we debugged in the previous video. So let's just see what happens here. I'm going to enter 4 values, and then I'm going to calculate the min and the average of the 4 values. These all go into an array. I run the program and SegFault. Okay. Why? Well, when you get a SegFault, you can put a whole bunch of printf statements in my code. So let's look at what that would look like. So I came into my code here. In main, I allocate an array of max size. Max size is 4. I then am going to read data into an array, and I never see this. I never see that printout, which means that I'm probably dying before then. And I went through and I entered all 4 values, so that maybe tells me that I'm going to die probably inside this array data to read data to array. I hit Control and clicked on the name, and it took me into the function. And so somewhere in here it's dying. Let's see what we got. So I put in 4 different values. I've got a loop here, enter the values, sure. I've got a count of the values equals 0, counts up, less than the size was passed in, and I go through this loop. And we're maybe not quite sure what's going wrong. I could look at this code for a while, unless I saw the exact line of code that's the problem. I don't get any real indication from the SegFault. So let's look up the debugger and see what happens. So I'm going to do the same debugger statement I did before, except instead of running SegFault, I'm going to run array entry crash. And again, it's now waiting for us. I'm going to run the debugger as before. I just have to remember to change this to array entry crash. Again, I'm going to do the target. So target remote 192.168.7.2 2001, and I'm in. I could set up a whole bunch of breakpoints and watch what happens, but let's just see what happens. I'm just going to code continue, and maybe we'll get lucky. As we did before, it was pretty obvious where the problem was. Okay, so it looks like GDB is now locked up. But of course, over here we can see that my program's waiting for input. Not a very good embedded program, but hey. Back on the right-hand side, we see we got a SegFault. Okay, that's great, except it told me that I got a SegFault in question. That can't be good. Let's do a backtrace and see where we are. Well, we're inside of read data to array, but the actual SegFault happened in something we don't quite know. So maybe that's a library call it can't figure out. I don't know. So we'll go up because the problem is likely in my code and not some other random library. Now this is interesting. It's telling me that the SegFault happened on calling scanf. Let's look at the code. So it thinks the SegFault happened on 52. It thinks we're right here. I'm trying to read in a floating point value into the address of new value. Well, new value is just a local variable. Let's print it. New value. Doesn't look particularly suspicious. If I wanted to, I could do print the address of new value. And that doesn't look particularly suspicious one way or the other unless I really took a close look at memory. So maybe in this case, I'm not quite sure. Looks a little crazy, so let's maybe go through and debug this a bit more carefully. So I'm going to do list 40. That'll tell me list from line 40. I'll hit enter to do it again. Okay, list. So I want to put a breakpoint on, let's say, line 46. So I'm going to do break on 46. I can do info B, and it'll tell me the breakpoints I have. I have a breakpoint in read data to array. Perfect. I can't back up. Once that ship has sailed, I can't reverse my program backwards after the SegFault. I'm just going to do a continue, and the program dies out. But that's okay. I'm just going to rerun it. So I hit up, hit enter, and then back here I still have GDB up and running. I'm going to reconnect, so that's going to be, I'm just going to hit up. I'm going to rerun my target remote. And I'm going to go info B. I still have my breakpoint enabled. I'm just going to run. So let's run this. So continue. Okay, I hit my breakpoint. Fantastic. So let's list the code. I'm sitting right here. Next thing I run is going to be this print statement. Let's check out the values I was given. So let's go print local args. Sure. Yep, not print info args. And data. Now data came in as, this is a pointer. If you know C much, arrays and pointers are basically the same thing. So it came in as a pointer, even though I told it was kind of an array. And it gave me the size. Size 4 is what we were expecting. If I go back to my code here, I've declared the max size is 4, and the actual data array is there. So that's good. As a trick in GDB, you can say, well, I don't want to treat this as a pointer. I want to treat this as an actual array. So I can say, I want to dereference data, and I want to tell you that there's actually 4 things here. So I'm going to say @4. And here are the 4 values inside of data. This is very, very useful. So far nothing looks suspicious. Let's go forward. I could just tell it to run with a continue, but it's just going to crash like it did before. So let's step through this. I'm going to step through this one at a time. I'm going to do what's called a step over, meaning I don't want to go into any functions. Like I don't want to debug printf and I don't want to debug scanf. So I'm just going to say next. Okay, we're going to set count to 0 next. Let's do InfoLocal. Looking for problems. Okay, count is going to become that. Let's do next. I'll execute that command. It's going to start going through this. So let's go next. Sure. I can check out what is print count. Count is 0. It's going to do a count plus 1. And when I go next, I'm expecting a 1 to appear here. Oh, it hasn't flushed the buffer yet. The buffer, even though it printed, it hasn't hit a line feed or hasn't done a buffer flush, and so we don't actually see the output here. We're going to set new value. Sure. Next. I'm just going to hit enter. It re-executes the previous command. And now we can see it flushed the buffer when it hit the scanf. Scanf flushed the buffer for me. So I'm going to type in a number. I'm going to type in a 1. So let's check out what we got here. So I'm going to do let's check out that new value, because scanf read a value into new value. So print new value. Came out a 1. That looks good. We're checking the sentinel here. we're basically looking to see if the value was entered was a 0. So I can print n sentinel. And it's a 0. So this should not trigger. Let's do a list. I'm currently here at line 55. It'll probably jump down next to like a line 60. I'm going to do an n just to next. Yeah, it went to line 60. Let's do a list and see where we're at. So we're down here. We're going to enter the data. We're going to put the data into the array. So let's just recap. We got print. I got to get on the screen here. Print data at star data at this will be like a false array. There we go. So those are the values that are inside my array. I can print new value. And so I'm expecting 1 to go in there. I'm going to do next. It'll now execute that command. It jumps back up and says, okay, you're now at the start of your for loop, but we still have access to all that data. So let's do that previous command, that print 4. That's kind of funny. I executed the command to stuff some data into my array. I put in a 1, and I got nothing in here. It's not there. Well, where did it go? Let's do a print count, because it went to data sub count minus 1. Ah, the count is 0. So if I print count minus 1, of course it's negative 1. Data sub negative 1 is 4 bytes before my array. Let me see if I can get there. So it's actually a bit, if I go print, I want to print the address of data minus 1, and it now holds a 1. So that's where it went. It went 1 byte before. Well, if you know anything about C, you know that the gloves are off when you're talking about memory access. And so I was passed in, as an argument, my data. Data came in from up here, and I declared it here. So when I did that, I clobbered some part of memory. If I do a backtrace, it says, okay, I'm inside a read data. Above me is, we're not quite sure who's above me. And then backtrace stopped. Previous frame identical to this frame. Corrupted stack. That ain't good. So what has just happened is my array out of bounds access has corrupted my stack. And by doing so, I get a SegFault when I try to go out of this function. So I can stop here. I can say, okay, I know what the problem is. My problem was down here. I have a negative 1, and I shouldn't. Right? A simple off by 1 error caused me this headache. I'm going to rebuild. I'm going to go back into here, and I'm going to continue, actually quit. I'll come back over to my embedded side, rerun the program, 1111, and it worked. I've solved that crash. Okay, so that's all I wanted to show here about the cross-debugging. Anytime you've got some crazy stuff happening, go and look at your memory. One last thing maybe I'll just show for fun. It's not actually going to help me here, I don't think, but there's a tool called Valgrind. It is definitely your friend when you're getting crazy behaviors in SegFaults. So I'm going to do Valgrind on, let's do Valgrind on SegFaulter. Actually, let me go back and make SegFaulter SegFault again. Let's rebuild this. Okay, I'm going to run it on SegFaulter. Valgrind on SegFaulter. There you go. It's running the memory check. Valgrind runs your program inside like a virtual machine, and so it takes a long time to run often. But what it tells you can be invaluable. So here, I ran through debugging, looks all good. It printed out my pointer, fantastic. Given pointer is this, and then it happily, cleverly tells me invalid read of size 4. I tried to access an int I didn't have access to. Dereference it. This is the line that tried to dereference it, and the address 0 is not stacked, mallocked, or recently freed. Basically, it's not a place I'm allowed to access. So Valgrind would have saved me all that trouble and given me that information already. Well, let's go back and make sure that I'm going to put the error back into my array entry crash. I'm going to rerun my my debug, and I'm going to Valgrind this time. I'm going to Valgrind array entry crash. It takes a minute to load because, of course, Valgrind's doing all that startup stuff. And I'm going to enter the same data I did before. In this case, I SegFaulted. I get some stuff here. It tells me, this basically tells me I got some memory problems, but jump to invalid address stated on the next line. It was going to jump to this location, and it's not a piece of memory it thought it understood, didn't know where that was coming from. And then it told me it terminated from here. Basically, it's not telling me anything interesting, or probably not anything really useful. So that shows me I've got some big problem. When I've got a problem like that, it doesn't know where it is. I've either given it the wrong binary, I've cross-compiled it incorrectly, maybe I linked in the wrong library, or if it's C or C++, you probably have botched memory. Check the stack, double check all your pointer and your array accesses, make sure they're within range. Okay everyone, that's all for today. Thank you very much for watching.